Welcome. Today's notes worksheet is entitled Describing Quantitative Data Graphically and Numerically Day 2. This is obviously a continuation of the previous notes worksheet, and it gives us an opportunity to further discuss center and spread of data distributions. So let's start at the top here. It says the 5-number summary and box plots. And so this is what I have, and if you could write this in as well, that would be great. And we can get started with a couple examples putting this together. So a 5-number summary contains 5 values. First is the smallest observation, or the minimum. The next value is the first quartile. Next value is going to be the median. Next, of course, would be the third quartile. And the last value in our summary would be the maximum, the largest observation. So those are the 5 values in a 5-number summary, talking about a data distribution. Now what we're going to do is visually represent the 5-number summary using what is called a box plot. And so a box plot is a visual representation and what it has, a central box, and if you've ever kind of taken a statistics unit before, it has extension lines. You've probably referred to those extension lines before as whiskers, sometimes called a box and whisker plot. So I think what we'll end up doing here is trying one by hand. Hopefully it won't take too long. I think we have some of the values in place already, so we can save ourselves a little time and energy. And then just see if we can draw one out here and get a good visual representation of a data set. So example 1, use the data set of biking times from the previous lessons. So we've actually already calculated some of these pieces right in here, so that's good. To create a 5-number summary and a box plot, and then draw any possible conclusions about the distribution. All right, that sounds great. So first of all, let's get that 5-number summary going. So we've got the minimum, the first quartile, the median, the third quartile, and of course, the maximum. Now the good news is we've kind of calculated these 3 pieces, as I already mentioned, so rather than doing it again, we can just put them in place. But let's see what we have going on. So the min obviously is the smallest observation, and because I was kind enough to put these from smallest to largest, there it is just on the first value. So 30.10 sounds great. Now the first quartile, if you remember, was sort of the median between the median and the first one right here. So I think we did this yesterday, and I'm just trying to get my values here. The first quartile, I believe we calculated as 34.02. That was kind of the mean right in between these 2 values right here. Okay, median we did on the previous lesson as well, and we decided it was sort of right in between 35.33 and 35.25. And so that would be our median right there. Again, we already did this, so there's no need to repeat the process. Third quartile, trying to refresh my memory as well, I think we ended up getting 35.92. And that, if I remember, was right in between these 2 values right here. It was the mean of those 2 values. And last but not least, of course, would be the maximum, and that would be the largest value right out here, 37.59. Okay, there's your 5-number summary. Really not too bad at all. So what we're going to do is try to be visual with this and see if we can make some generalizations from it as well. But basically what we want to do is create some type of number line, a scale, so to speak. So I'm going to go by 2s just from what I see. And it looks like I've got a min close to 30, so I'm going to start at 30. Again, nothing magical about this. And then 32. Just try to keep them evenly spaced if possible. And something along those lines right there would do. Great. And what we're going to do is very simply plot our 5-number summary on our number line right here. And from there, we get the central part as the box and the whisker plot as sort of the outskirts. Okay, well, let's get that going. 30.10, so if you get a chance just on your paper there, let's get that plotted and then move right across. It looks like the first quartile was just over 34, so right there. My vantage point's not great at the board here, but I'm going to do the best I can. Median was 35.29, so something about right there. Great. 35.92, right there. And last but not least, 37.59, so probably about right there. And there, of course, would be the 5 values from our 5-number summary plotted. And now what we want to do is create a box around the central component. So remember the IQR yesterday? That would be the difference between here and here. So let's go ahead and create a box around those values, the first quartile and the third quartile. The median, which actually happens to be the second quartile, would be right in there. That's looking pretty good. And then the extension lines going out to the max and to the min, and you see that piece right there. All right, not too bad, all things considered. I guess I would pose one question your way, and then we'll move right on to the next piece, is just based on this box and whisker plot right here, would you characterize the distribution as left skewed, symmetric, or right skewed? What do you think? Well, from my vantage point, it looks like the length on the left whisker is quite a bit greater than the length on the right whisker, and this part of the box, the left part of the box, is greater than the right part of the box. So the range in between here and here is greater. So it seems, long story short, is it looks to be skewed to the left. We've got more values, a greater range of values to the left of the median than we do to the right of the median. So that's what I'm just going to write up here, and I hope you would agree with that conclusion. This would be somewhat of a left skewed distribution. Again, my box plot is not great by any means, but I at least I think can make that conclusion from it. All right, great. Let's go ahead and maybe do a couple different pieces with example 2, and now we can go ahead and use the graphing calculator here. So it says, here is a set of data in minutes representing Mr. Meyer's biking time from his house to Boulder High. So this would be in the morning, waking up and coming to school. So from my house to Boulder High, use a graphing calculator to create 2 box plots and draw any possible conclusions about the distribution. So what we're now going to do, everybody, is put in the 2 distributions. Me riding home in the afternoon, that would be the distribution from example 1. And me riding from home to Boulder High in the morning, this would be the distribution in example 2. Let's see if we can put them both in. I actually have mine both in, but I'll ask you to pause the video and get yours in, and then we'll compare and contrast a little bit. So guys, let's get an opportunity here to put this in, use some of the technology. So if you get an opportunity, here's what I'm going to ask you to do. Go to second and then y equals, and we're going to turn stat plot 1 on and stat plot 2 on. So go to 1, highlight on for me, and notice the type here, of course, is a variety of things. I think we've primarily used the scatter plot, but let's go ahead and highlight the box and whisker plot right there, and then it should be ready to go. Okay, so stat plot 1 on, box and whisker plot. Then if you would, when you have that, and again, pause if you need to, go second and y equals, go back again, and let's go to number 2, please. We're going to turn the second one on. Again, turn that on. And same deal, box and whisker plot. Now the only difference is we have to go ahead and get our list differently than the first plot. So you probably have it defaulted as an L1 right here. So what you're going to do is type in L2 like you see on the screen. And by the way, L2 would be second and then the number 2. So you want to go ahead and come down here and do second and the number 2 to get that as L2. So again, just make sure all this is set up exactly the way I have it, if you would. And then we're going to go ahead and hit Stat when you're ready. Move it over to I'm sorry, go ahead and hit enter on that. And here's where I will ask you to clear out anything that's in there, and please enter the data sets in if you get a chance. So it'd be great for you to do this as well, get a little practice with it. If you just don't feel the need, that's fine. But I've got my data sets in. So this one is the one from example 1. This is in the afternoon, me riding from Boulder High School to my house. This would be from example 2. And this is in the morning, me going from my house to Boulder High School. All right, great. Pause for a sec, get them in, and then I'll get rolling on my piece. All right, so let's take a look. We've got 2 box and whisker plots. I believe everything is set up. And just remember, all you have to do to see the best window possible is hit zoom and number 9, and there you go. So I believe this is the one from example 1. This is in the afternoon. This is from example 2. This is my morning ride. So take a look at that, and I'd ask you to come up with a couple conclusions there. By the way, this is the one we did by hand. So take a look at the one you drew for example 1. Actually, mine's not too bad, all things considered. All right, so I'm going to do this on my board. I'm going to put like an L1 and an L2 just for the 2 data sets. And let's just come up with some conclusions there. I would ask you to come up with some conclusions as well, kind of stare at that for a moment. And then I'll tell you what I wrote, and if you have something a little different, that's fine. Maybe you can run it by me and see if we agree. All right, so here we go. L1, L2. And so L1, I think we already decided was a little more left skewed. We did it by hand, and we made that determination. And I definitely see it on the graphing calculator as well. It's a good confirmation of that piece. So the first one was a little more left skewed, whereas the list 2 seemed to be a little more symmetric. Let me bring that up one more time. That's at least what I thought when I saw this. So look at this one right here. Obviously it's a touch to the right, but certainly quite a bit more symmetric than the other one. Okay, good. That's one conclusion I have. Look at the range. The overall range, that's what's kind of interesting here. The overall range is quite a bit greater, but which IQR is going to be greater? That's what's really interesting about this. I think this range is greater, but this IQR, that's from here to here, is greater than it is from here to here. Interesting pattern right there. So I'm going to write for this one right here, IQR is greater. The overall range from max to min is greater here, so I'm going to write that as well. Fascinating. 2 different ways to really talk about variability, but that looks good. Let's see, anything in terms of me biking in the afternoon versus the morning? Well, it looks like for sure that the morning rides are quite a bit longer than the afternoon, so these are all kind of shorter, a little further this way. Okay, so it looks like the biking times are longer in the morning from this second data set right in here. In fact, if you look at the 3rd quartile, that's less than the median of this one right here. So remember, 3rd quartile is like almost talking about 75%. So 75% of my rides for this data set are less than 50% of the rides for this one. Interesting. All right, well, anyway, let's just get this moving along here. Biking times definitely are longer on this one. Hope you kind of agreed with that statement as well. If you have some other stuff there, that's fine. We can kind of talk about it in further detail. I don't see the need at this point in time. But just wanted you to see the graphing calculator usage with some data sets and coming up with the 5-number summary. We'll do that actually in a little bit as well here. Good. All right, well, let's move forward. On the previous notes worksheet, we found a way to talk about measuring spread, and that was with the IQR. And now we have a secondary way to talk about spread with what is called the standard deviation. So the notation on this, everybody, is kind of an S, little x right there. So the standard deviation of our values measures the average distance of the observations from their mean. All right, perfect. Now there happens to be a little formula for this. I won't make you calculate using the formula. It's a little cumbersome. We'll probably do it primarily off the graphing calculator, but we'll at least investigate it a little bit so you can see. So first and foremost, it requires a square root, if you can kind of put that in, and I'm going to see if I can fit this in. So it's 1 divided by n minus 1 times what's called sigma, which really refers to the sum, so this is a Greek letter sigma, of all the values minus, this is an x sub I, by the way, minus x bar squared. You'll see this come into play in just a little bit, so if you're looking at it, the notation itself and like, wow, what is that? Let it go for a little bit and we'll see if we can develop it together. So one more time, it's a square root, and you've got 1 over the n minus 1 times the sum of all of these values squared. So we take each observation, subtract the mean, and then square it. Okay. Well, let's see at least where that comes into play. Maybe we'll do one by hand. Maybe we'll get it off the calculator. We'll just have to see. Alrighty. Well, let's do the investigation that you see on your paper. So I picked a pretty small set of data to work with. Let's see if this does justice here. So the investigation says, let's work with this data set representing the number of books read by students in my daughter Leah's class in a week. So it looks like we have 1, 2, 3, 4, 5, 6, 7, 8 students in my daughter's class. And the poll was, how many books did you read in a week? And these were the numbers that came up. And so as it says in your paper, let's follow this along. It says determine the individual deviations from the mean. All right, so the first order of business, guys, is we have to find the mean. So I'm going to just do this off to the side. So remember, x bar for the mean. Mean is very simple. Add them all up and divide by the number of values. So if I add all these up, 2, 4, 7, 10, 14, 20. So it looks like the sum of the books would be 20. And what did we say? 2, 4, 6, 8 values total. So to find the mean, of course, I get that piece right in there. And 20 divided by 8 would be 2.5 books. So the mean, of course, is 2.5 books. And by the way, that would kind of be right in here. I don't want to think of it as a median, but 2.5 is obviously right in there as the mean. All right, keep that number in the back of your mind. And so what we want to do now is talk about the individual deviations. And so in this case, there are going to be 8 of them. So write on your paper, if you would, individual deviations. All right, perfect. Now here's the idea. Each one of these values is a certain number of units away from the mean. So let's start with this. 0, and by the way, the mean was 2.5. So 0 is how many units away from the mean of 2.5? Well, because it's below, we're going to use a negative. So I hope you would agree 0 is 2.5 books away from the mean, but because it's below, we would say the deviation is negative 2.5. So throw in a negative 2.5 for me. Put a little comma. All right, next piece. How far is 1 away from the mean? Well, 1 is 1.5 away from the mean, but lower, so it's negative 1.5. That would be the deviation. Obviously, this also, negative 1.5. All right, 3 down, a few more to go. How far is this away from the mean? Well, that one would be negative 0.5. All right, now, we're above the mean now, so we would consider these positive deviations from the mean. So how far is 3 away from the mean of 2.5? 0.5. Another 3, another 0.5. So got most of these taken care of. 4, how far is that away from the mean? 1.5. And last but not least there, how far away is 6 from the mean, which is 2.5? It looks like it's 3.5. So those are the individual deviations. I hope everybody agrees on those pieces, how far we are away from the mean, either below it or above it. Beautiful. Now here's what we want to do. We want to take the average, right? We want sort of the average, as it says, the average distance of the observations from their mean. So average would mean adding them up and divide. So let's see. Here's what I'm going to ask you to do. Add and divide by 8. What do we get? And in this case, when you add them up and divide by 8, we end up getting a big fat 0. Does that mean that on average, these individual values are 0 units away from the mean? No. No. What happened is because we had negatives and positives, they sort of canceled each other out and unfortunately did not give us what we wanted. We want the average distance away from the mean. And so that we need a way to fix it. And that's the question obviously on your paper here. So let's move right into that piece. It says, how can we fix the problem of positives and negatives canceling out? Now there are two ways to do it. For some greater mathematical purposes, one way is done over the other. So if you're thinking about taking absolute value, that is one way to do it. But the way that's done statistically is to, in order to get rid of the negative piece canceling out with the positives, is to square each of the deviations. And that's what we're going to do in a moment there. But that's what I need you to put on that piece. So in order to talk about these individual deviations and avoid the prospect of negatives canceling out with positives, we're going to square each of these values. And when we square each of these values, they all turn positive, and they allow us to work a little better. Okay. So now, as it says on the next piece, determine the individual squared deviations. So what happens when I square each of those values? So I've got my values up here. If you want to just write them down, we can get moving on this. Square negative 2.5, you get that. Perfect. Square 2.25, square negative 1.5 and you get 2.25. Square negative 1.5, you get that again. And right down the line, guys. If you square each of those values, they all turn positive. And so these would be the individual squared deviations. 1, 2, 3, 4, 5, 6, 7, and then 8. And notice, now we don't have to worry about negatives canceling out with positives. We're in a pretty good position. So there's one little catch to this. It says, of course, determine the sum of the squared deviations. Remember the idea, we want average distance, and then what is called the average squared deviation. And notice what it says on your paper here. And you're going to require a more in-depth statistics class to look at why this is. Instead of dividing by the number of terms in the distribution, we actually divide by one less than that. So I know it seems intuitive to take these now and add them up and divide by 8, but we actually end up taking these and dividing by 7. Okay? So statistically, that's kind of why. And if you want to take a look at that in a little more detail with me, we certainly can. But again, it would require quite a bit more math that's outside of the scope of our unit to go into it. Anyway, what we're going to do is add those up and divide by 7 as opposed to 8. And when we get that value, it's what's called the variance. Okay, so add them up. If you get a chance, grab the calculator, add them up. And when I added mine up, the sum ended up being 26. So we're going to take 26 and divide by 7. And when I take 26 and divide by 7, I end up getting 3.714. Now guys, this is what we would call the average squared deviation, sort of the variance. And we have to be careful of our units. Remember what we did is we took the deviations which were in books and we squared them. This would be squared books, squared books, squared books. And so in essence, That's the unit. I know it seems kind of crazy to write, but I want to do it there to emphasize the point. That would be the variance. It's in squared units, in this case, squared books. And so, long story short, because we squared all of the deviations, our units are in squared books. So how do we go from squared books to books? Take the square root. And so what we end up doing is taking the square root to get back to the correct unit, which would be books, and the resulting value is what is called, there we go, the standard deviation. So square root of 3.714, and we end up getting about 1.92. And that is your standard deviation. And so what that means is, and I'm going to write this down below right here just so we can get this all together, and then we'll move on. 1.92 is the average distance of the values in our data set from that mean of ours. That's the way to talk about spread, and we'll do a lot of work with standard deviation. So just want to be clear on what standard deviation represents. If we go back to our data set, and I'll go back one more time there. If we go back to our data set, on average, these individual values are 1.92 units away from our mean of 2.5 books. That's what it means. Again, it's a way to talk about how far away it is from the mean. Perfect. Hey guys, just very fast here. Look at that, that formula. And maybe, just maybe, it makes a little more sense. So remember what we did. We took each value and essentially found its distance away from the mean. We squared them, got the individual variations, squared them, and took their sum. That's what this sigma means. Add them all up. So again, just one more time. Individual deviations, squared them, and then took their sum, divided by n minus 1 as opposed to n, and then square rooted. So that's the formula that we just investigated, I think in pretty decent detail, and that's how we got our standard deviation. Okay, good. Let's maybe just do one on the calculator here and write a couple more things in and kind of bring this down to a conclusion. So example 3. The following data set represents the number of minutes Mr. Meyer practiced guitar each night for a week. Find and interpret the mean, then find and interpret the standard deviation. So remember, when we look at a data set, we're finding measurements of what we would call center and measurements of spread. This is one way to do it. This is a measure of center, and standard deviation is a measurement of the spread of the data. All right, well, mean, not too bad. Let's do that pretty fast here. So x bar, again, I know you can pretty much do this in your sleep. Just add them all up and divide by, in this case, 7. So this is the number of minutes I practiced guitar in a week. I kept track. And so on average, it would be about 35.29 minutes. So I guess, you know, however you want to write this, you're more than welcome to, but this would be the average of 35.29 minutes of practicing guitar each night. Okay, so measurement of the center, sort of a typical value. That looks great. Mean would work very nicely here. Now, guys, what we want to do is get the standard deviation. Rather than doing this by hand, and you're actually more than welcome to, if you feel it's almost quicker than entering the data on the calculator, you're more than welcome to. And I can work through that with you individually if you'd like. But I'm going to just do it on the calculator here, just give you an idea of what the technology would look like. So guys, I'll ask us to go back to Stat and Edit. And let's clear out that first list if we could. And let's go ahead and put this data set in place. So on Monday, I practiced for 42 minutes. etc. right down the line there, Tuesday, Wednesday, Thursday. Okay, looking good. All right, so first order of business, guys, is to put in your data set. Not too bad. And here's sort of a nice window that we're going to take a look at over the next, well, at least this notes worksheet and into the next two notes worksheets as well. So guys, hit Stat for me and move it over to Calc, and you'll see something at the very top called One Variable Statistics. And as a matter of fact, the One Variable Statistics, it's going to give us our 5-number summary, which we started this lesson with, and it's going to give us our X bar, and it's also going to give us the standard deviation. So let's go ahead and hit that. One var stats, and we've got that piece right there. Notice a couple things have come up. Number one is look at X bar. There it is, 35.29. That's what I calculated right up there. Great. And then here's the one right here, guys. That's the one we're focused on, the standard deviation of our data set right there. And we get about 10.95. So that's what I need us to put in. We'll do that momentarily. And by the way, just kind of down below, 7 data values. Look at the 5-number summary, everyone. We've got minimum, quartile 1, median, quartile 3, and max. Kind of cool, huh? So we'll use this over the course of this lesson and some of the homework. You don't have to do a lot of the calculations. Let this calculator help you out. Anyway, I've got 10.95 there. So let's do it. So standard deviation was this right here, and that's 10.95. And again, what it represents is the average distance of the values from the mean. Okay, so the mean was 35.29, and our 7 values here, on average, are 10.95 units away from that mean. Okay, hope that makes pretty good sense. So we've got mean and standard deviation. The others that we talked about were median and IQR. So just, talking about when to use which measurement for center and when to use which measurement for spread, this is what typically works. And we'll go with this in just a sec and get into our last example. So the median IQR kind of go hand in hand very nicely. That was that 5-number summary, basically. Median and IQR coming from that 5-number summary typically is used for a skewed distribution. So remember we talked skewed versus symmetric. So median and IQR typically is a better choice if it's skewed, sort of a better representation, or outliers too, by the way. I'm going to just kind of put that in parentheses there. If there's some outliers, typically this is a better representation of the data distribution. So median IQR for skewed or outliers, and then let's see, and then kind of back this way, and we would say probably the mean and the standard deviation for reasonably symmetric data distributions. Okay, symmetric distribution with no outliers. Oh, that looks great. Okay, so center and spread, everybody. What do you say we do just maybe one more here? And if you feel like you kind of have this all together in your mind, that's perfectly fine. What I would like to do is maybe one more data set and maybe just take a look. So let's see what we've got for example 4. For their final project, a group of AP Stat students investigated their belief that females text more than males. They asked a random sample of students from their school to record the number of text messages sent and received over a 2-day period, and here's the data set. All right, so what we're going to do is put this in L1, put this in L2, and again, let's see if we can put this together in a coherent way. Let's get this from the one variable stat. So as a matter of fact, guys, before I'm even going to do this, on your paper, just one variable stat. Make sure you put that in place. And then, if there's anything we can do to sort of make some conclusions from this, we'll do it. Okay, well, let's do it one more time. Good comfort with the technology here. And if you think you know how to do this, don't feel obligated to go all the way through this example. You can just copy in some stuff. But I certainly don't mind going through it. All right, so I'm going to clear this out. Clear this out too. And I think they're both set up pretty nicely here. I think they're already ready for box and whisker plots and so forth. So just a matter of putting in the data. Okay, guys, here we go. If you want to pause the video and do it yourself or just kind of wait on me, that's fine. But I'll try to do this as fast as I possibly can. I'm not great with this. I'm sure you can type quite a bit faster than I can. But again, I'll do the best I can. Hopefully I get them all in correct for us. All right, one down. Let's move them on over, and let's get the other one going. Okay, I'm getting closer here, 127. Here we go. And looks like I've got one extra on that one. That looks good. All right, so one variable stat on these. Let's see what I have got. So first thing I'm going to do here is stat, move it over to calc, and do a one variable stat. This will give me the list 1, and so hopefully that works for us here. I've got my mean, standard deviation, and the 5-number summary. So guys, let's take a moment and put this in place if we could. It's all pretty much right there. All right, so I'm going to get my values in my table. I've got them on my paper, so it'll be a little easier. And let's see what we've got. All right, guys, so here we go. Mean texting for males was 62.4. Standard deviation, so on average, the values are 71.4 away from the mean. Min was 0. Quartile 1 was 6. Median was 28. Quartile 3 was 83. Max was 214. And IQR, remember in this case, quartile 3 minus quartile 1. So this minus this was 77. So that would be the IQR, sort of the distance in that box in the box and whisker plot. All right, good. Now let's go get them. We want to do a one variable stat. So I'm going to do a one variable stat on the L2. And let's see if that comes up nicely for us. There we go. Notice, look at the X bar, everybody, quite a bit greater. Pretty much more than double, by the way. So we've got 128. And again, I have this on my paper already. Obviously, I can just get it from the calculator. And so on average, the distance away is about 116 from the mean. Min was 0. 34 is the quartile 1. 107. 191. I got 379 as the max. And again, quartile 3 minus quartile 1, I get as 157. All right, really nice there. Bring up the calculator one more time. Let's see. And again, all that data is right there. If you want to come down, here's your 5-number summary right in here. Min, quartile 1, median, quartile 3, and max. Wonderful. Let's hit zoom and number 9. And we've got a decent box and whisker plot. It looks like they're both right skewed, by the way, just from what I see. Look at that, both right skewed. And look how much more, obviously, that the females text more than males. You know, if you look at this median is greater than this third quartile. So certainly quite a bit greater there. I'll write a couple conclusions down, and then we can kind of wrap this on up there. Hopefully the calculator is making sense, and if it doesn't, just let me know. But here's some conclusions that I drew from it, and you can kind of pause the video and make your own conclusions and run it by me. But they're both right skewed. That seems to be the case right there. So females, it looked like, had greater variability. And obviously you look at those box and whisker plots, and you can see that the females text quite a bit more than males according to this data distribution. So females text more than males. I'm sure there's some other ones that we can draw. I think I'll kind of stop it at that point there. Maybe just bring this up one more time. Again, females texting more than males. So what this basically means right here is half the females here are greater than 3/4 of the males right up there. So certainly by quite a bit. Okay, well, let's round this out at this stage. If you have some questions with the technology, please don't hesitate to ask. Hopefully I didn't shortchange too much on there. Thanks.